Good morning, everybody. It's nice to be here and to see you in this nice, clean, cool environment rather than out in the paddock for a change. Okay, so today I just wanted to go through some of the agronomy work we've done that we hope will be useful to you in the coming year. Okay, just a quick recap of 2021. We had that early break with Seroja. We got the very high area. We had good pricing at the start of the season, increasing to those incredible levels, which led to high imports, and we had this lovely soft end to the season. So happy days. Comparing that with 2022, like 2021 was very sensible. We had good indicators, good early break, lots of canola. Coming into 2022, we've got the high price. There's going to be a lot of pressure for a high area of canola, but we've still got the changing climate. We don't know when the break will be. We've got limited seed and variety choices, high input prices, particularly nitrogen. We've got that high stubble and a disease risk. So today I want to recap our early sowing work because I think could potentially fit in very well with trying to get as much canola area as we can, and follow that with some establishment research we've been doing to make that early sowing even more successful. And we'll look at some density research I've got for the seed choices. And I'll touch on nitrogen, and Jeremy Curry will follow up with that. And then we've got Jeff covering off with the disease. Okay, climate change. We all know what's happening. Can't read it all. Have to go here. Okay, so we've got less rainfall events in autumn, as we know, and less growing season rainfall. Increased temperatures, and the hotter spells are getting longer, bigger, and longer. So we're really talking about the early sowing was primarily to address that first question about reduced rainfall events. If we can extend the sowing window from the middle of April to the third week of March, that's more than 20 days extra we've got to capture those increasingly rarefied rainfall events. But as it happens, the early sowing does address each of those climate change problems. So recapping, this is the work from 2019 and 20, GRDC supported. And what I want you to see here, so it's 2019 and 2020 trials from Mullawa, Wongan Hills and Dale near Beverley. We've got the yield at the vertical axis and the early sowing times on the bottom axis. And all I want you to see here is that when we've had the very early sowing on the 18th of March or the 8th of April, they were our highest yielding plots in all cases. Whoops, didn't want to go on. Can I go backwards? Yep, this one. Okay, so highest yields for those. I'm sure there's another point I need to make there. Okay, and when we look at that with the climate or the weather we're seeing on the sites, so this is Mullawa 2019, vertical bars obviously rainfall, the black crosses at the bottom of the incidences of frost, and the orange is the days where it was over 32 degrees, so dangerous for canola when it's flowering. So plotting on now the flowering curves, the different times of sowing. So the blue one is the first time of sowing, very early sowing in 18th of March. So we can see it started flowering in May. We can see that the flowering was extended by the rainfall, and we've got a much longer flowering period than the subsequent seeding times, either at the 30th of April or the 6th of June. So these are all the places where it fits in with the climate change. So as we've already mentioned, you've got that much greater opportunity to catch the rainfall events, the bigger time of flowering, period of flowering, and that's of course where we're setting all the yield potential. There's a much reduced risk of these hot temperatures coming in at the critical time of flowering for canola. And with the higher temperatures and reduced growing season rainfall, we're having more severe terminal drought, and of course it'll be reducing that as well because the development's a little bit earlier. Nothing's for free though. Of course we have a few problems, and one of the things we found a lot was that because we're trying to seed very early into those hot conditions, can have establishment problems. Over here. So although we've had the seeding opportunity and you've got the seeding in, but then we're prone to pressure from the follow-up rains here. Frost, we're more at risk of having those nasty frosts just at the end of flowering, which of course is the most dangerous time when canola plants are hard to recover. And the last one, again, that longer period of flowering just leaves us more prone to disease. Okay, that's just a recap of that. But obviously, when you get the sowing opportunity, you need to evaluate your risk and reward. Oh, I know what I missed on that first one. When we had the highest seeding at the very early or the early April seedings, when we went after that, so 29th of April, we lost more than half a tonne on average over those sites, and it was 1 tonne average when we went to the 20th of May. So that's the rewards you need to compare it with. If you get an early seeding, you've got that opportunity to seed, and it might not be there later, obviously. Okay, how early? This is Merredin on the 12th of March, and it was unfortunate that it was Merredin. If it had been anywhere else in the state, it probably would have been brilliant, but it got hit by frost, of course, and that went 0.8 tonnes. That grower, that was a farmer paddock, and he has done it before, and he will go again, but maybe the week after that one. So from those same trials, this was our field establishment. So I just want you to see that with the early seeding on the 18th of March, and we always got a much lower field establishment. So these were irrigated plots, so clearly it was to do with the temperature. So 2021, so we discussed that a lot at the crop updates, and there's a lot of discussion about how hot was too hot, so we swung straight into some establishment research. I had hand sowing plots at South Perth, a field trial at Georgina near Greenough, and some lab work. So this was the 5th of May where we started, so less than 2 weeks after the crop updates. So this is our attempt at precision seeding. So we used the jig there to make the pressure in the ground, and we individually put a single seed, 7,000 single seeds over the 7-week period, and each of those was individually mapped and monitored. So this graph is just the maximum temperature over the seeding period, is the orange line, and the vertical lines is our seeding events. And you have a look at there, you can guess what will happen to the establishment. And where we did have the periods of high temperature, especially a long duration of high temperature, is when we saw that the establishment was reduced. So particularly this one here, we've got several days here of the high temperature, and it's causing this really low field establishment. And then later in the season, we're right back up, and later in the season was mid-April, we're right back up at really high field establishment. And there was a lot more going on in this trial with depth and varieties as well. Okay, and so some of the pictures of what we saw, burnt cotyledons here, a lot of cupping of the cotyledons, and later on we saw a lot of silly seedling as well. So the field trial, we started that at the 17th of March, and the photos is when I went up for the 3rd time of sowing, which was just after Seroja. So half the shops were closed, and there was hurricane lighting, and the others was all quite weird. You can see that the first sowing was about a month old by then, and the second seeding had got hit with the sandblasting. But I was really surprised that, even the early one, 17th of March, 53% field establishment was much better than I was expecting. I was expecting 30%. And 93% on the 31st of March. That was much higher than I thought. So in some ways it didn't work, but it shows us it can be successful. So why was that 93% on the 31st of March? Any takers? It was cool. Thank you, someone. So, so the first one here, we can see after seeding that long period of heat, and after the second seeding, although it popped up quickly, presumably the seed was coming up at this cooler period. Okay, so it's good. We can have successful establishment with the cooler conditions, and we did get good yields for those early seeding times.
What's going on with the 120% yield establishment?
Oh, well, you're out there and you're doing a certain number of quadrants per plot, so obviously there's variability. So it means we've got a lot. Maybe I should have put it down to 100, but I wasn't fussed. So, yeah, just this sampling error. And I haven't got time to go into it. We've got a good procedure with a lot more counts than normal for that establishment work. Okay, so now we're at the labs. can't see the numbers, but in the lab we did some germ tests at 20, 26, 30 and 35 degrees. And as you can see on the graph there, as the heat increased, we got a reduction in the number of normal seeds that emerged, and we got an increase. So these ones still emerged, these orange ones, but they were abnormal. So if you're in your home germination test, you may not realise, but they're probably not going to be very good plants or be part of your viable crop. It's just a quick picture of them there. And also we found that as the heat increased, the speed of germination decreased, so they got slower. 5. Yep. And so the hypocotyl length reduced. So at 35 degrees, we only had 11 millimetres hypocotyl length compared with 28 millimetres for 30 degree thing. Thank you, Mr. Wilkins. I was there ready and armed with my ruler when they pulled them out. So establishment, we haven't got it sorted. We know there's a lot going on. I can only suggest at this point that you watch for the temperature forecast as well as the rain if you're seeding early, and we're doing more research in 2022. Okay, the canola seed. I was going to mention some variety type work from that previous one. And look at our Meckering density trial. So this is back at the work in 19 and 20. And the red line on all these graphs is the Inviga T4510. It's an early mid variety. And we found in the trials that we had, those 6 trials, or in all of the 8 trials actually, that it was either the highest yielding or the equal highest yielding, whether it was sown very early or very late, apart from this single event at Dale. So great variety to have in the shed to be able to use according to as the season progresses. And the other 2 that we have shown on there is the short one in black, High 350, and the SF Ignite in blue, the long season variety. Okay. This is 2021 work at Meckering. We had bonito in there, anything from 20 plants per metre squared right up to the ridiculous at 320 plants per square metre. And in 2021 at Meckering, there was no yield reduction with that ridiculously high level of density. But bear in mind, we did have that soft finished. Okay, so then for the hybrid seed, I had different treatments, and that's why you can see the different shape of the curve, because I went for that down to 5 and 10 plants per metre squared, up to the 80. And you can see we did have a significant difference in the yield from those. So comparing it, okay, so I was surprised to see that the yield increased right up to this 80 plants per metre squared, and I don't think we're going to have the seed to do that this year. But if I compare the yields with this one, with the traditional 40 plants per metre squared, at this one we lost we had 77% of the yield, so we lost 23% here, and we lost 28% there with the low yields, with a low plant density. But there was no difference in the gross margin, no significant difference in the gross margin. So that puts us back. We're still happy with the work previously done by Bob French, Mark Seymour and others, because it's the optimal density for our profits that we're looking at. So in 2021, I think it's a great season that we should be retaining any OP seed and grading it. When you're seeding the OPs, use the big seed. And if you've got big seed, if it's over a 2 mil sieve, you're going to have to use 5 kilos to get those target seeding rates. So don't treat your OPs like your hybrids, and you might be forced to use the OPs because you can't get the hybrids. Okay, nitrogen, very briefly. Trial at Meckering, as always, we did get increased yields, but declining oil. That oil difference was only $30, so we just focus on the yield, and there was a significant difference in the yield, but not the gross margin. So, if looking at it for next year, there's no need to be throwing too much nitrogen around. And although this wasn't a particularly high yielding site, the nil plots were 50% oil, so I think it was quite happy, and it was comparable to the local MVT. In Katanning, we had another one that was even more responsive, definitely a difference in the yield according to the nitrogen rates. On the nitrogen rates there, it was from 30 up to 300 kilos. And when we look at the gross margins for that, I've put them in with the pricing for 2021, $1,000 of canola and $550, and you can see that it's quite responsive. And if we look at some of the pricing we might guess at for 2022, $800 for canola and $1,000 for urea. The line's a lot flatter, of course, but it's still responsive. Whoops. But still responsive. But if it was on the fitted line, then we wouldn't have had a significant difference there. And just in brief, looking at the work we've got going through for next year, I want to consolidate that early sowing work under natural conditions. With the primary bit will be focusing on field establishment and finding the parameters that work for that. And we're going to look at nitrogen and density for the early sowing situations. Thank you.
Cool. All right, thanks, Jackie. All right, so I'm going to be talking about some of our work we've been doing in the high rainfall zone around canola nutrition. So just a bit about the project itself. This project is titled Optimising High Rainfall Zone Cropping for Profit, and it's a GRDC investment with DPIRD, CSIRO and FAR Australia involved as partners in this project. So I'd just like to acknowledge GRDC and also the crew at CSIRO and at FAR for this project. The project started in 2019 with a series of workshops that we did around some of the high rainfall zone areas. So Dandaragan, Esperance and Albany held workshops. And really we wanted to gauge from growers and agronomists I guess, were there key constraints, were there key knowledge gaps that they were seeing, particularly in the high rainfall zone with regards to where we could explore improving our management. There'd been research that had shown that if you look at your water limited yield potential in the high rainfall zone and what people were actually achieving, the gaps in the high rainfall zone were as big as any other rainfall zone. With up to 2 tonnes for cereal and 1 tonne for canola. So it was really around, what is causing that yield gap and what can we do to address it. And one of the key things that came out of each of those workshops was this idea around nutrition, that if we've started to really address our subsoil constraints with things like deep ripping, if we're growing good hybrid cultivars, we're sowing early, and we've got this great yield potential, do our nutritional packages actually have to change as we're starting to achieve yields of 3-4 tonnes per hectare? And so that's what this trial series I'm going to talk about today that we've done in Esperance is really around. So this is the 2020 trial, and the 2021 trial is laid out very similarly, where you can see we've got blocks of plots of different N rates, and like Jackie has, we've gone up to rates up to around that 300 units to really try and get on top of the curve. And I guess at the time of doing this, we thought some of these rates were quite ludicrous, but having talked to some of our growers in the Western Australian high rainfall zone, there's some quite high rates going on to canola crops with some good results. But I guess the question is, we can push nitrogen so far, but as we do push that nitrogen further, do our other macro and micronutrients start to become limiting? And so that's what we've tried to address with the other range of treatments that we've applied within each nitrogen rate. So we've applied what we thought were reasonable rates of phosphorus, potassium and sulfur as kind of an old treatment. And then we've stepped down one or more of these different macronutrients, and we include some micros in 2020. So we're hoping to see, particularly as we push our yield potential higher, would these become limiting, or is nitrogen still the main driver? Before I go on to the results of our trials, thought we'd probably be relevant to look at what we should expect based on our soil test results. Fortunately, in the canola space, we've got some awesome work. Brennan Boland published 3 papers around phosphorus, potassium and sulfur around 2006, 2007, and some pretty nice response curves to things like Colwell P. And so you can see, based on our Colwell P values in 2020 and 2021, we probably were expecting a bit of a phosphorus response, but nothing too extreme. Although it should be noted in both those trials, the phosphorus actually increased at the 10 to 20 centimetre level to around 20 units. So possibly a phosphorus response in both seasons. The DGTs, which I'm not all over, are just suggesting, you guys might have a better idea of it than me, but suggesting 2021 more available phosphorus than in 2020. In terms of potassium, likewise on the curve, we're looking at around 60 units for our Colwell K. And so once again, we're down that bottom end of the curve, probably not expecting massive potassium responses. And sulfur, this is where the two sites really deviated. The 2020 site soil test results suggested that sulfur should be reasonably okay, was 2021 suggesting that we might see a response to sulfur. So the idea is, as we're pushing these high yields, would these come true, and would we see greater deficiencies with our high yields? All right, so in 2020, we ran 4 nitrogen rates, starting at 15 units up to 300. At 15 units of N, we were really surprised to see how good the yields were at 2.3 tonnes a hectare. When we looked at how much N we were actually getting from the soil, it was probably double what we were expecting. And yeah, quite a surprising result there, considering the history of that paddock on the research station with lack of legumes. A great yield response to increasing our nitrogen up to 100 units, going just above 3 tonnes. At 200 units of N, we're around that 3.5 tonnes per hectare mark, and that's where it plateaued. This would suggest that the grower practice is typical would be 150 units in a lot of our areas, and looks like they're around the right mark based on the 2020 results. As mentioned, the key thing we wanted to look at was, do some of these other nutrients become limiting? Our soil test results suggested that maybe we'd see a phosphorus response, but these were pretty high yields. We didn't actually put a nil in. We kind of considered that growers would put some level of phosphorus on, and potassium, sulfur, and some of these trace elements maybe becoming a bit more optional. If you compare when we applied reasonable rates of all of these nutrients to what we called our base treatment, there was nil difference between them, nor was there in any of these other combinations of macronutrients that we applied. And even when we applied the ludicrous rates of these macros, negligible yield response. The key thing we actually found with that was the impact on plant establishment. In 2021, yields are a bit lower, pretty high waterlogging pressure in this season. But once again, a reasonably high yield response of going from 100 units up to that 150 mark. So again, our standard grower practice around the 150 units in both the seasons, doing a pretty good job of topping out yield. But what was pretty evident going through the season, with the onset of probably flowering, and around that July, we'd had 3 months of pretty wet weather, was we started to see some deficiencies in the crop. So the photo on the left and the photo on the right. On the right, that's our healthier looking plots. And on the left, we had quite a few of these plots which had discoloration of flowers. They weren't flowering very healthily at all. And the key difference between these two plots was the sulfur that we had applied. So we expected we might see a deficiency, and we were seeing these symptoms. These photos were in early August. And come October, you can see the plot on the left with the lack of sulfur hadn't really set much yield. It was still flowering, I guess, trying to keep going and setting more yield versus the one on the right, which was maturing reasonably healthily. The only thing to point out here is that you could also see it post-harvest in the redness of the stems in the sulfur-deficient plots. You could literally walk around, you had a map of your site, the plots you'd put sulfur on, the ones you hadn't. So in terms of our other macronutrients, if we look at our phosphorus, even when we applied nil phosphorus, we weren't seeing a response at this site, which was really quite surprising. But our 3 plots where we didn't apply any sulfur, this is at the 100 N rate, you can see a yield, a negative yield of 300 kilos you've lost by not applying that sulfur. But as we pushed our yield potential higher with higher rates of N, you can see you've actually ended up costing yourself the better part of 3/4 to a tonne of yield by not applying that sulfur. All right, so I guess in summary, the trial sites we picked, we weren't particularly looking for deficient sites. We were just looking for bog standard high production areas in the Esperance Port Zone. and looking, would we induce some deficiency with our higher nitrogen rates and hopefully some good seasons, which we were, for the most part, lucky to have. They were both highly responsive to N, which we'd expect in our part of the world. But in 2020, minimal responses to other nutrition, noting that we had a basal P rate of 15 units, whereas in 2021, that large sulfur response that we saw, particularly with those wet conditions. And so it's somewhat of a null result, but somewhat of a positive, I guess, that in light of these high fertiliser prices we might be seeing, even in some of our high-yielding crops, soil testing and things like that, still indicating your best areas of return, and really targeting those areas. Yeah, so that's all I've got, so thank you.